Hello, pre-algebra. Mr. Lawrence here with your flip lesson for March 28th. Remember, we're having the test on Friday. Today is Wednesday. Um, Today we need to talk about some dilations, and tomorrow night's video will be review, kind of covering everything. All right, so let's see here. We have two different types of dilations, right? We have ones where we do it about a point, and the point is the center of the dilation. And then we have ones where the origin is the dilation, right? Now the one with the origin is the one that uses coordinates. The way you remember that is, the origin is 0, 0, 2 coordinates. Should be an easy thing to remember. Now there's two types of dilations. We can have a scale factor of like a whole number like 2, in which the shape will get larger, or we could have a scale factor of say 1/3 where it'll get smaller. Okay, I'm going to do it both ways for each type. So this first type is going to be with point A at the center. That's my center, point A. And then I'm going to do it with a scale factor of 3. Okay. Well, I look at the length of AC. I know A prime isn't going anywhere. And AC is 1 unit long. The new AC, A prime, C prime, will have to go 1, 2, 3 units long. All right. A is not going anywhere. AB is 1, 2, 3 long. A prime, B prime will have to be 1, 2, 3, 4, 5, 6, 7, 8, 9 long, and there's B prime. And then all I have to do is connect B prime and C prime, and there we go. All right, my triangle should be 9 times larger, not 3 times, because the base and height each increased by 3. If I figure out the area of the black one, that would be, let's see, base times height divide by 2, right? Okay, and the base is 1 and the height is 3, and divide by 2, I'm going to get 3 over 2, or 1.5, right? If I do the area of the red one, I'm going to get the base to be 3, the height to be 9, and then I'm going to cut it in half. That's going to be 27 over 2, and if I cut 28 in half, I get 14, so this must be 13.5. All right, now to see how many times larger it is, I will do 13.5 divided by 1.5, right? And there you go, it's 9 times larger because the base got bigger 3 times and the height got bigger 3 times. If you were thinking it doubled, then I should have got double of this answer. 1.5 doubled is 3, but I didn't get 3. I got something much, much larger. Okay, so that is a scale factor of 3. This time I'm going to do it with a scale factor of, say, 1/2. And let me see if I can get rid of these red ones without losing everything. Let's see. There we go. Okay, this time my scale factor is going to be 1/2. And it's done very much the same way. I know that A prime isn't going anywhere. AC is 1 unit long. A prime, C prime will be 1/2 a unit long. Okay. A to B is 3 units long. A prime to B prime will be 1.5 units long. And then I will connect the two, right? Okay, and my area got smaller by 1/4, right? Because I need half the base times half the height, and then divide by 2. All right, well, 1/2 times 1/2 is 1/4, right? And the original one would have just been base times height divided by 2. What's the difference? The 1/4. And multiplying by a 1/4 is the same as dividing by 4, as many of you know. Okay, so that's where the point's at the center. Now we'll come down here and we'll do some where the origin is at the center. So the origin is the center of dilation. And remember, the origin is not 0, it's the point 0, 0. Now the polygon, or whatever it is we're doing a dilation of, does not need to touch the origin. Okay, so let me see here. Oops. I'll just stick with a basic triangle, kind of like this one. Okay. And I'm going to call this A and C again, and I'll call B up here. Okay. So I need the coordinates for this. A is at 2, 1. B is at 3, 4, 1, 2, 3, 4, 5, 4, 5. And C is at 1, 2, 3, 4, 5, 1. All right, 5, 1. Okay, so first let me do a scale factor of, let's go with 3 again. All right, actually it's not going to stay on there, I'll do 2. All right, my scale factor 2, A prime, I'm going to multiply them each by 2, 4, 2. B prime will be 8, 10, and C prime will be 10, 1. So C prime will be here at 10, 1. A prime will be at 10, 2. Silly mistake. There we go. So there's C prime there at 10, 2. A prime will be at 4, 2. 1, 2, 3, 4, 1, 2. There's A prime. And then B prime jumps all the way up to 8, 10, which is right there. B prime. And I'll connect my triangle. And that one's a little curved in, but it looks like a larger version. Okay, again, the area increased 4 times because the base got bigger by 4 and the height got bigger by 4. Excuse me, the base got bigger by 2 and the height got bigger by 2. 2 times 2 is 4. Okay, now for a scale factor of, say, 1/2, I'm going to do the same thing. I'm going to multiply the black ones by 1/2. So A double prime will become 1, 1/2. I go 1 unit and then half a unit, and there's A double prime. B double prime will be 2, 2.5. So I go 1, 2, 1, 2.5. So there's B double prime. And then C double prime would be 2.5, 1.5. Right? 1, 2.5, 1.5. Oop, there's a mistake there. It's 1/2. Sorry guys, I'm going too fast. Half of 1 is only 1/2. Sorry about that. Okay. You know how I knew it wasn't right? Because A and C are on the same line, and this wasn't turning out that way. All right, so I'm going to go 1, 2.5, and then 1/2. And so there's C prime, and I'll go like that. Okay, and there it is. And that's it. Those are dilations. All right, tomorrow night we'll talk a little bit about the magnification problems and things like that. All right, and you'll be ready for the test on Thursday. Okay. All right, Mr. Lawrence signing off. Have a good night, everybody.